Hey everyone, so we're going to talk about two of the nominated problems from 4.4. This is the part one. You'll see more of solving with exponential and then logs as we go into next week after your nice big long weekend. But we're going to talk about 11 and 19. So both of these are going to require a calculator. So if you're not using your graphing calculator yet, you want to be using that, or at least a standard calculator with log buttons. So for 11, we've got 4 plus 3 to the 5x equals 8. And so for this one, it's really important that we get the exponential term by itself first. So we subtract 4 from both sides, and we end up with 3 to the 5x is equal to 4. And this is why we need a calculator, because if this is like 3 to the 5x is equal to 9, or something that could be written in base 3, you wouldn't need a calculator. But in this case, we'll take the log of both sides, and then the exponent comes down. So we end up with the equation 5x times ln of 3 is equal to ln of 4, so log 3, log 4. And then we just divide both sides, ln of 4 over 5 ln of 3. And this is where you just want to grab your calculator out, and you end up with x is equal to 0.25. Get my calculator out. What was that last digit? It's going to be another 2. So main thing, make sure you've got your logs worked out, and make sure you get your exponential term by itself first. All right. Now we're going to look at number 19. And number 19 is tricky because there's two exponential terms. Thankfully, they're already by themselves. So when we take the log of both sides, we end up with ln of 5 to the x equals ln of 4 to the x plus 1. And here's where it's tricky. So just like before, you're going to bring the exponent down. So this becomes x times ln of 5. And this whole exponent comes down. So this is parentheses x plus 1 times ln of 4. And so what you want to remember here is that ln of 4 is just a constant. You can even just type it into your calculator. I don't know exactly what it is because it's going to be an irrational number, but 1.38. Like, you can plug in these decimals. I'm not going to because you're rounding them a little bit and then you get weird answers. But I'm going to treat this like a decimal and distribute it. So then I've got x times ln of 5 is equal to x times ln of 4 plus ln of 4. Then I've got my like terms, just like you would if you had like 6x plus 4 equals 4x plus 7. You're going to get your x terms on the same side. So these are just decimals. Pretend they're decimals, or you can actually write them out as decimals. So I'm going to subtract that over, and we get this. We can combine the like terms. I know I'm being a little sneaky with my here. And then you can just type this into your calculator and solve for x. So x is equal to the ln of 4 divided by parentheses ln of 5 minus ln of 4, which means that x is equal to 6.213. Again, I'm just looking at my calculator because all those logs, you don't know. As I said in the notes, you can use log base 10 instead of the natural log. I will always use the natural log. Your math teachers in the future will always use the natural log. The only reason to use the regular log is if you're doing something with scientific notation, for example, something that's already in base 10. So hopefully these two examples are helpful. There were other problems nominated, which is awesome. I'm really glad to see a lot more of you using that. And you can use these examples to help you figure out maybe some of those other issues you were having. Feel free to reach out, and talk to you later.